Right, Simon? Here if you get the fraction, if you simplify, if you substitute this value 20 by 19 and 45 by 19 in that z value, then if you get the value 235 by 19. Here if you want to write that maximum value 235 by 19 or 12.3 something, 12.3 something. So that's why if you get the value what here, so approximately otherwise if you want to write here 12.3 or 235 by 19 value is the maximum at the point 20 by 19 comma 45 by 19 value. Okay na? Right. Right, Simon. Fourth question. Here what given, Simon? Fourth question. Minimize z is equal to 3x plus 5y. Z is equal to 3x plus 5y. Okay na? Minimize z is equal to 3x plus 5 such that it is subject to constraints given what? Subject to constraints. Subject to constraints. So which constraints given, Simon? Subject to constraints x plus 3y. X plus 3y is greater than or equal to 3, comma x plus 5 is less than or equal to greater than or equal to 2, greater than or equal to 2, and comma x comma y is greater than or equal to 0. Already explained about maximum minimum values the same model. One inequality only given, two inequalities given. Subject to constraints, two conditions here, and object to function here. Same like process we apply, we get the bounded and feasible region, and we get the minimum value at that particular point. Okay now. Next fifth question also you know, same fifth model also what we will see here. Z is equal to minimize, maximize. This one maximize here. Fifth one what we will maximize. Okay now, maximize. Z is equal to 3x plus 2y. 3x plus 2y. Next one, subject to constraints. Subject to constraints. Subject to constraints. What we can see here? X plus 2y. X plus 2y is less than or equal to 10. Comma. Next one, 3x plus 5 is less than or equal to 15. Is less than or equal to 15. Comma. X comma y is greater than or equal to 0. Okay now, these questions you do homework means minimum value one question given, maximum value. These two are the bounded feasible regions. Bounded feasible region. Already we know that how to find out the bounded feasible region. First we converted these inequalities into equations. After that we find out the coordinates of the particular line equation, and those points are plotted on the graph. And we shaded region. Then we substitute a horizon point in the inequality. Which inequality is true? Then we draw the shaded region towards horizon. Otherwise, which inequality is false? Then if we draw the away the horizon, we draw the shaded region. Then if we get the common point, common region determined by the constraints and non-negative constraints, that portion is called feasible region. And after that, if we find the coordinates of the common points. Coordinates of the common points. After that, if you want to draw the table of the common point table, from the table we identify easily that where the given function is maximized or minimized. So that is already explained that type of models also. So that's why fourth one and fifth one no questions. Next sixth one is what we can minimize subject to constraints. Okay na? Subject to constraints. Which constraints you can see here? 2x plus y. 2x plus y is greater than or equal to 3, comma x plus 2y is greater than or equal to 6. X comma y is greater than or equal to 0 values. Okay, ma'am? So these are the conditions. If you want to find out from these conditions, what we find out by the required value. And these conditions, what we require here, minimize the value. So then how to find it? Already we know that this process. So first what we will see, we have to minimize. We have to minimize. Which one we have to minimize? Objective function x plus 2y value. After that, if you want to know the subject to constraints, subject to constraints. Which constraints? 2x plus y is greater than or equal to 3. X plus 2y is greater than or equal to 6. X comma y is greater than or equal to 0. Now we convert inequalities Inequalities into equations. Into equations. Okay na? Now inequalities what my dear? 2x plus y is equal to 3. So this is equation 1. And another one what remember? X plus 2y is equal to 6. This is equation 2. And next one what? X is equal to 0 or y is equal to 0. These are the line equations. Now from equation 1, if you want to find out the coordinates from equation 1. Now if you want to draw the equation 1. Simple. X y value. Now what we find out here? X is equal to 0. Then y is equal to 3. Y is equal to 0. But problem means what here? Y is equal to 0 means if you get the fraction 3 by 2. Otherwise y is equal to 100. Y is equal to 1. Then what if it means x is equal to 1 value. Okay now next from equation 2. From equation 2. Simple. From equation 2 if you want to draw this one. Again if you get the x coordinate and y coordinate. X is equal to 0. Then automatically y is equal to 3. Y is equal to 0. X is equal to 6 value. And these two are any common point. If you want to solve equation 1 and 2. Solve equations 1 and 2. Okay na? 1 and 2. If you want to solve in these equations means what? Equation 1 multiplying with 2. Then what happens? 2x plus 2y. 2x plus 2y. Both are cancellation. Multiplying with 2. Equation 2 multiplying with 2. Equation 2 multiplying with 2. 2x plus 2y. So 2x plus 2y. Otherwise one thing we do. Here x is equal to how much more? 6x minus 2y. So from equation 2 what we will see? X is equal to 6 minus 2y. X is equal to what? 6 minus 2y. Mostly I think this is the unbounded feasibility theorem. That's why common point does not exist here. So after that if you want to solve that one, first we want to draw the graph of this given conditions. Okay na? X dash x axis and this one y axis. Now see horizon. Now which point they are given here? So which point if you want to consider here? First on x axis is 0 1 maximum 6 value. 1 2 3 4 5 6 and 7. And y axis maximum value 3 there. So that's why 1 2 and next one 3 next 4 and 5 also we get. So first if you want to draw this graph, then what we consider points here? X is equal to 0, y is equal to 3. X is equal to 0, y is equal to 3. X is equal to 1, y is equal to 1. Means here x is equal to 1, y is equal to 1. Now if you want to draw the line passing through, see ma. So passing through this one. Okay na? That is the one line equation. And another line equation x is equal to 0, y is equal to 3. Again same. X is equal to 0, y is equal to 3. Next one x is equal to y is equal to 0, x is equal to 6. Now see what? So if you want to draw passing through, so this is the another line equation. So this line equation what we represent by x plus 2y. X plus 2y is equal to 6. Now this one, this equation if you take means here what from 2x plus y is equal to 3 value. Okay now if you want to shade the portion, here any intersect value is not required. So first inequality is 0 0 if you substitute means 0 plus 0 0 is greater than or equal to 3. True or false? So false case means if you want to draw this region away the horizon. And next one 0 0 greater than or equal to 6. This one if you want to draw away the horizon means this side. If you want to draw this side. So now this portion is the unbelievable portion. So like this portion if you want to consider here there on this side. Okay na? So now this portion is representative feasible region, but this is unbounded. This is not unbounded. So first we find out the values. So already explained unbounded process, no? But yes, no, first explain unbounded process. But if you take the corner point, which are the corner point? So this is one corner point, and this is one corner point, and this one is another corner point. Suppose this corner point 6, 0. Now this corner point be of 0, 3 value. Then what we will see again from the graph? From the graph, the feasible region from the graph, the feasible region is unbounded. Okay, now the feasible region is unbounded. Then the coordinates, the coordinates of the corner points are A of 6, 0 and B of 0, 3. Now if you want to construct the table, which table we have to construct means corner point. Suppose if we take from here corner point table means corner point at Z. So these are what here corner points. Z is equal to, this are x plus 2y. Z is equal to x plus 2y. So first point what we get A of 6, 0 and B of 0, 3. 6, 0 is this value 6 value. 3, 0 is this value 6. Yes, sir. The given region is unbounded, but both values are the same. So means the maximum value is how we consider minimize the minimum value of Z has the objective function Z has at both points the same value is the same value. So at that time whenever same value if you take means if you not identify the maximum value and the minimum value in unbounded case also directly if you want to run that value only minimum value of the given function. So that's why what run means by your final conclusion minimum value of Z is minimum value of Z is 6. Minimum value of Z is what? 6. At all the points on the line segment joining the points on the line segment joining the point 6, 0 A of 6, 0 and B of 3, 0, 3. Okay na? So that is the condition in unbounded only feasible region. But if you get the two values of same values at that time you are not identifying which one is the minimum value and minimum value of the given function minimum value. So that's why what we consider here minimum value of Z is 6 at the point all the points on the line. If you take any point on the line then first should be the given 6 only given. Okay na? Line segment joining the points A of 6, 0 and 0, 3 value. Okay na? Eighth question, maximize and minimize objective function. Z is equal to and subjective constraints given one. Same model. 7th also explain same type of model only. Maximize and minimize the given function, linear function. So that's why what we learned first here we have to maximize and minimize Z is equal to x plus 2y. Z is equal to x plus 2y. Next one, subject to constraints. Subject to constraints. So what we have given subject to constraints? X plus 2y is greater than or equal to 100. 2x minus y is equal to 0. Next one, 2x plus y is less than or equal to 200. Next, x comma y. Now negative constraint. X xy greater than or equal to 0. Now we convert. Now we convert inequalities into equations. Inequalities into equations. Okay na? Inequalities into equations. So first one say x plus 2y is equal to 100. This is equation 1. And next one 2x minus y is equal to 0. Equation 2. Next one 2x plus y is equal to 200. So equation 3. Then again if you want to know x is equal to 0, y is equal to 0. These are the line equations. Then what happens from equation 1? From equation 1, if you want to find out the x value, y value coordinate, suppose in x, y. So x is equal to 0, y is equal to 50, y is equal to 0, x is equal to 100. Then again what means from equation 2. From equation 2. From equation 2, we want to take again x, y value. So from equation 2 already this is line passing through the horizon. This line passing through the horizon. So that table also not required. Otherwise, if you want this calculation from equation 3. So from equation 3, if you want to run, this is the x value and this is the y value. From equation 3, y is equal to 0, then x is equal to 100. Y is equal to 0, x is equal to 100. Then again what we will do here, x is equal to 0, then y is equal to 200. Okay na? Now if you want to draw the graph of this function, so then see only here positive values there. So horizon x dash, this value x, and this one y, and this one y dash. Now we want to take 20, 40, 60, 80, 100, 120, 140. Okay na? So next one, if you want to take the values 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Okay na? Now these are the coordinates plotting on the x-axis and coordinate, just values. Now we plot the coordinates. First equation what they know, x is equal to 0 and y is equal to 15. Now if we take here 50 value, after that so x is equal to 0, y is equal to 0, x is equal to 100. Okay na? Now if you want to draw the line passing through these 2 points. So this is the inequality. Which inequality is one? X plus 2y. X plus 2y is equal to 100. So another case from equation 2 we left it from equation 3. X is equal, y is equal to 0 and x is equal to 100. So this is the point. And when x is equal to 0, y is equal to 200. Okay na? Now if you want to draw the line, so this one passes through this one. Line equation passing through this one. Okay na? Otherwise if you want to draw this one, straight line equation what means? Line equation passing through this one. Okay na? Now this equation again what we are learning here. So this equation 2x plus y is equal to 100. 2x plus y is equal to 100. Now this is the passing through the horizon. Next one passing through the horizon. So this line equation is passing through horizon. So this line equation what we are learning, 2x minus y is equal to 0. 2x minus y is equal to 0. Now we have shaded portion. Already we know that the horizon substituted in this case, then this is not satisfied. 0, 0 is greater than or equal to 100, so that is not satisfied. So that's why if you take away from the horizon, and second, this case what 0, 0 less than or equal to 200. So if you take towards horizon, so this shaded region you take one towards the horizon. So next one, this one already told about this type of any line passing to the horizon here means above the line or below the line. If you take any one point above the line, if you take the point 0, 20, then what we have here 0, 20 in this inequality. 0, 20 means this value is 0 and minus 20. 0, 20, 0, 20. I think this one less than or equal to this inequality is second case inequality less than or equal to 0. This is what less than or equal to 0. So here also less than or equal to 0. Now in this inequality also it is up to the point above the line point 0, 20, 0 minus 20 is satisfied. Otherwise, if you are below the value 40 minus 0 is not satisfied. So that's why if you take the value this region, in this region, if you want to take the component, see this is the side line and this is the side line. Now this is the common portion of the given. So this is the feasible region. So this is the feasible region. Feasible region. So this is the feasible region. So in this region, if you take the point, now these are the corner points. Which points? So this is the corner point and this is the corner point. Now this one is a corner point. So this one also a corner point. Now see the corner points what we are here. A of this one 0, 50, and this one you don't know this one B of this value also you don't know C of this value already we find out 0, 200. Okay now B and C points if you want to come up. So that's why what we are doing here solving. So these two equations solve. First what we will see again, solve equation. Which equations if you want to find out B? Line equation and first equation. Equation 1 and 2. So solve equation 1 and 2. So equation 1 there what they see here x plus 2y is equal to 100. Equation 2 what 2x minus y is equal to 0. Y is equal to 2x. Now y plus 2x is means 2 into 2x, 4x plus x, 5x. So then this value x is equal to 20. When x is equal to 20, then automatically y is equal to 40. Now this is the coordinates of B point. Then what are the coordinates of B is equal to 20, 40. Now these are the coordinates of 20, 40. Okay now. So next one, if we solve in this equation, solve again equation 2 means equation 2 and 3. Equation 2 and 3. See what equation 2 and 3 if you want solving, then what we are going to get the points. Equation 2 3 what we get 2x plus y is equal to 200. Here y is equal to here also 2x. Then what we are coordinates here y plus 2x means 4x is equal to 200. X is equal to 50. When x is equal to 50, then y is equal to how much? 100. Okay now, x is equal to 50, y is equal to 100. Then C coordinates what we are here 50, 100. Now we are the values here 50, 100. So these are the corner points of the feasible region. Okay now if you want to run from this condition, what we are here from that data, if you want to run here from the graph. From the graph, the feasible region, from the graph, the feasible region is ABCD and it is bounded. Okay now na? So after then what remember? The coordinates of the feasible region, the coordinates of the corner point, the coordinates of the corner points are A of 0, 50, next B of 20, 40, C of 50, 100, and D of this value how much more? 0, 200 respectively. Okay na? Respectively. So first we find out the corner point from the case. But what we require by here? Those points where the objective function become as the minimum or maximum. So that's why what we will see here. So that's why we prepare the corner point table. Where means here what we are here corner points and z is equal to, in this case z is equal to x plus 2y objective function. Now see ma corner points, if you substitute in the objective function, if you get the maximum or minimum values. So first one we have a of 0, 50. Okay na? Next b of 20, 40, 40. Next c of 50, 100, 100. Next d of 0, 200, 200. Now see first 0, 50. Then what we will get this value? 100 value. Next one what we will 20 plus 80. So 8 to the 20 plus 80 means again 100. Next value was 50 plus 100, 250. This value, so sorry, 50 plus 200, 250. Now this value we want to means 400. Now these two values, if you observe these three values there from the given data, these two are called what is minimum values. Minimum. This is value of maximum. Okay na? So what we are doing here? The maximum value of z is 400 at the point d of 0, 200. Next what we will see again? The minimum value of z, the minimum values of z or z. The minimum value of z will be 100. The minimum value of z is 100 at the points at the line segment, joining the points at the line segment joining the points A of 0, 50, and B of 20, 40. Okay na? So this is the maximize and minimize of the given objective function at that particular corner point. Right, Sima? 9th question only maximize given. The given function is maximize given. So same process of maximize or minimize, minimize. 9th question of maximize z is equal to, subject to constraints given x is greater than or equal to 3, x plus y is greater than or equal to 5, x plus 2y is greater than or equal to 6. Okay na? Now generally what we explain here, we have to maximize the given condition, we want to maximize. So subject to the constraint, then the constraints we are converted into equations. Then equation 1, equation 2, equation 3. Now we solving from equation 2 if we taken is no coordinates of x comma y. So equation 3, coordinates of x comma y value. Okay na? First we solving equation 1 and 2 or equation 2 and 3. Why means these are the point of intersection in the diagram. So now if we draw the, generally we draw the x axis and y axis. On the x axis we take what? 1 to 8 or if you take here 1 to 7. Now the first equation x is equal to 0, y is equal to 5. Then x is equal to 0, y is equal to 5. This is the point. Okay na? So after that y is equal to 0, x is equal to 5. Now this is the another point. Now if you join that white line, that is the x plus y is equal to 5 equation. And similarly x is equal to 6, y is equal to 0. X is equal to 6, y is equal to 0. So means here 6 value. And again what more? X is y is equal to 3, x is equal to green line that is represented the second equation. Okay na? So after that if you want to find out this point of intersection means this line and this one x plus y is equal to 5. Both are intersecting at a point. And similarly x plus 2y and this line x plus y is equal to 5 also intersecting at this point. Okay na? Now if you want to shaded region means how to find its here in this inequality 0 0 greater than or equal to 0. So this side away the horizon, right? Away the horizon. And here again 0 0 greater than or equal to 0. This is also away the horizon. Next and here y is greater than or equal to 0 and x is greater than or equal to 3. So this is the portion. So this means if you shaded means this is the unbounded feasible region. Unbounded feasible region and coordinates of the corner points this one. So whenever unbounded feasible region means the process, then already I told the process. Which process? Then first we find out the maximum value of the corner points. Which corner point given maximum value? First we find out the maximum value. So that's why what we do here? Corner points z is equal to minus x plus 2y. That is equal to minus x plus 2y value. Now see, if you want to find out x plus 2y, so then corner points what we get? A of 3 comma 2, A of 3 comma 2, and B of 4 comma 1, C of 6 comma 0. Now if you find out a corner point, the maximum value, so z is equal to substituting is minus 3 plus 4, that is equal to 1 value. So minus 4 plus 2, that is equal to minus 2 value. So this value minus 6 plus 0, that is equal to minus 6 value, 6 comma 0, minus 6 value. Okay na? Now this is the maximum value of the given condition. But this is what unfeasible region. When unfeasible region, so that is a may or may not be maximum value. May or may not be maximum value. How do we find out the maximum value? That is only means then if we draw the another inequality, we consider another inequality of the half of the resulting plate and the feasible region any common points there. Then that is not a maximum value. It has no maximum value. Otherwise, any common points not there. That point only maximum value. So that's why what is here? The maximum value. The maximum value of z is 1. But feasible region is unbounded. But feasible region is unbounded. Okay na? Feasible region is unbounded. Therefore, 1 may or may not be maximum value of z. May or may not be maximum value of z. Okay na? So may not be maximum value of z. Then we draw the graph. We draw the graph of inequality. Now, which inequality we consider? Subject function is greater than ax plus by is greater than capital M given. So that's why minus x plus 2y is greater than 1. Is greater than 1. Okay now? And check whether the resulting open half open plate, has points in common with feasible region or not. Feasible region or not. Okay na? Now see ma, feasible region or not means if we draw on a dotted line, so that dotted line is represented which equation means x plus 2y is equal to 1. Actually that is the inequality, but we convert it into equation and we draw this one. Now this is shaded if telling me this is the false case. False case means when we draw the shaded the portion above the line. So above the horizon, away the horizon means if it there must have some common point. So okay na, the feasible region has common point. That is, the feasible region has a common point with this inequality. That's why this is not a maximum value. So that's why what we done here, the feasible region, the feasible region has common points with the feasible region has common points with minus x plus 2y greater than 1. Okay na? So that's why z has no maximum value. Z has no maximum value subject to the constraint. Maximum value subject to the constraints. Subject to the constraint. Okay no? So infeasible region problem here, then if you run your unbounded feasible region here, then if you run these conditions. Right, so 10th question, last one in the exercise. Okay na? This one also you want to convert to maximize. Same process. We have to maximize. Z is equal to x plus y. We have to maximize z is equal to x plus y. Subject to constraints. Subject to constraints. X minus y is less than or equal to minus 1. Minus x plus y is less than or equal to 0. X comma y is greater than or equal to 0. Now we convert. Inequalities into equations. Inequalities into equation. Now see x minus y is equal to minus 1 and another one minus x plus y is equal to 0 and x is equal to 0, y is equal to 0. That is the line equations. Now we want to solve this one. Then what about x, y? Suppose x is equal to 0, y is equal to 0 means what? Plus 1. Y is equal to 0, x is equal to minus 1. And from equation 2, see now x, y. X is equal to 0, y is equal to 0. Y is equal to x passing through the origin. Okay na? So y is equal to x over this one minus x. Y is equal to or x is equal to y passing through the origin. Then if you want to draw the graph of this one, see now. If we take here x is equal to minus 1 also, so that's why x is equal to minus 1, 0, 1, 2, then this value 3. Here 1, 2, and 3. Now see points if you want to draw here number line. So first one inequality means x is equal to number 0, 1. 0, 1 means this point. And next one what? 0 to minus 7. Now this point. Now if you extended this line, this is the line. Okay na? Next one is horizon. X is equal to 0, y is equal to 3. So this is passing through horizon. Okay na? So this equation what from here? X minus y is greater than or equal to minus 1. minus x plus y is less than or equal to 0. Now inequality is substituted means what? Here 0 is less than or equal to minus 1. So 0 is greater than or equal to minus 1 number, 0 is less than or equal to means away the order, means this case. Next this number minus x, 0 is less than or equal to 0, so satisfied means, but here this is passing through the original number. If you take any one point above means 0, 1. In this inequality we substitute minus x plus y is less than or equal to 0 plus 1 is less than or equal to 1. So failure case is one. Okay na, failure case. Then another one what? 0, 1, 0. Minus 1 plus 0 is less than or equal. This is the satisfied. So means point if you take this side. Okay na. Now this is the shaded region. This one. Now similarly here this side also same, if you consider this portion. Okay na? So there is any common point there. So this portion is upwards, this portion is downwards. So at the time what we done here, what we observing from this graph, here any feasible region is does not exist. So that's why what we done, there is no from the graph there is no point satisfying. There is no point satisfying. There is no point satisfying all the constraints. All the constraints simultaneously. Okay now. So from the graph what we have seen, there is no point satisfying all the constraints simultaneously. So thus the problem is having no feasible region and no feasible solution, and hence no feasible solution. So feasible solution also not exist now. Therefore what Z has no maximum value. Z has no maximum value. Therefore Z has no maximum value. So Z has no maximum value. Okay na?